In the previous lesson, we learned how to convert from rectangular coordinate to a polar form. In this lesson, we are going to see how we can convert from polar form to a rectangular coordinate. We know that complex number in a polar coordinate could be represented as r cos of theta plus I sine of theta. This is the polar coordinate. How do we convert this back to our rectangular coordinate? So converting from polar coordinate to a rectangular coordinate, there are two main things you need to get it done. First of all, you need your radius. You also need your angle. So if you are having your radius and your angle, then you would be able to convert it from a polar coordinate to a rectangular coordinate. So converting from a polar coordinate to a rectangular coordinate, we know that rectangular coordinate is represented a plus bi. So to find a is equal to r cos of theta, and to find b is equal to I sine of theta. Let's prove this. So proving this, let's go back to our Cartesian plane. So if we have our angle here, this is A and this is B. Here is, let's name our angle alpha and our radius r. So given alpha and a radius r, how do we find A and B? So finding A, we have the adjacent and we have the hypotenuse. So that means A So to find A, we have our adjacent. A is adjacent to the angle, and we have our radius, which is the hypotenuse. So taking our angle, we have cos of alpha equals adjacent, which is A, the adjacent A over our hypotenuse r. So making A the subject, we have A to be equal to r cos alpha. The same way when we want to find B, finding B is opposite to the angle alpha, and we have our hypotenuse, which is r. So using sine of alpha equals our opposite B over our hypotenuse r. So making B the subject, we have B to be equal to r sine of alpha. So and simply, A is equal to r cos of theta and B is equal to r sine of theta. So representing or converting from polar form to a rectangular form, you just need this formula and you are able to go. Let's take an example. In the previous video, we looked at how to convert from a rectangular coordinate to a polar coordinate. So taking some of those examples, we have example 1. We have example 1 to be 5 cos 323 plus I sine 323. So this is in a polar form, and to convert it into a rectangular form, a plus bi, having a radius of 5 and an angle of 323 degrees, we have our a to be equal to r cos of theta, which is 5 cos 323. That gives a value of 3.99, and in approximation is 4. And we have b, which is the imaginary part. That one too is r sine of theta, which is 5 sine 323. That also gives a value of -3. In a rectangular form, a plus bi becomes 4 minus 3i as our answer. Let's try another example. Taking this example, this is in polar coordinate, of which is exponential form. This is in exponential form, which is also a polar coordinate. So the very first thing that we need to be able to convert it back to rectangular form is we first need our radius, which is root of 5, and we also need our theta, which is 63.43. Now converting it to a rectangular form, we have a to be equal to r cos of theta, which is root of 5 cos 63.43. That gives a value of 1. And we also have b, the imaginary parts, to be equal to r sine of theta, which is root of 5 sine 63.43. That also gives a value of 2. So our a plus bi becomes 1 plus 2i, 1 plus 2i as our rectangular form. Let's take another example. We have 3 root of 2 into bracket cos 45 plus I sine 45. Comparing this to our polar form, we have our radius to be 3 root 2, and we have our angle theta to be 45 degrees. Converting it to a rectangular form, we have our a, the real part, to be r cos of theta, which is 3 root 2 cos 45. That gives a value of 3. And we also have the imaginary part, which is b, to be equal to r sine theta, which is 3 root 2 sine of 45. That also gives a value of -3. A plus bi now becomes 3 minus 3i as the final answer. Last example, we have 3 root of 2 into bracket cos of 315 plus I sine of 315. Comparing this to the polar form, we have our radius to be 3 root of 2, and we have our angle theta to be 315. converting it to a rectangular coordinate, we have our a to be r cos of theta, which is 3 root of 2 cos 315. Compute 315. Computing this gives a value of 3. We also have our b to be equal to r sine of theta, which is 3 root of 2 sine of 315. That also gives a value of -3. The negatives here shows where it lies in the Cartesian plane. Our standard form a plus bi now becomes 3 minus 3i. If you have any question, you can leave it in the comment section and we will attend to you. Thanks for watching.